Hi, I'm Jeff. I know a few of you I've seen before at Techorama and other things here in the Netherlands. Quick, little story before we get into this. It's kind of funny how these things happen because it was what? It was last fall, Eric, right? I think it was last October. Oh, maybe it was in the spring. We were coming through, and John and I travel quite a bit and speak at a number of events. And we were coming in, and we were standing in line for passport control at Schiphol, getting ready to come in. And I texted, so I put something on Twitter. And Eric, who we followed each other on Twitter, kind of writes like he liked it and gave some response. I said, oh, hey, John, we should just invite him out and hang out and have drinks. And now over the last, whatever it is, 6 months or a year, we've gotten to know Eric really well and got nice friendships built up. And that led to this. So whether you live here in Amsterdam or you live elsewhere around the Netherlands, whatnot, at events like this, these are great because you can meet people and opportunities come that you would never ever expect. So I saw it was awesome. Everyone was talking and having a nice time beforehand, but make those connections because amazing things happen just from walking up to somebody and saying hello. So I'm Jeff. I'm from St. Louis, Missouri, which is basically right in the middle of the United States, at Jeffrey Strauss on Twitter. We're going to talk a little bit about ASP.NET Core. Who has, so I get a kind of feel for the audience, who's got ASP.NET Core code in production today? About a third to half, all right? Cool. That's good. That's good. Who's still maintaining ASP.NET full framework stuff today? ASP.NET Web Forms or Web API, things like that today? Yeah, or has ever done it, right? So ASP.NET historically has been built foundationally on a couple of core things. Things like if you've ever worked in ASP.NET full framework 4.6 whatever, based on things like global ASAX and web config. If you've lived in this world, you're familiar with all of its benefits and how great it is and also how terrible it can be. One of the issues historically, and this has been always the case with ASP.NET, right, is from its very early days through web forms, web API, SignalR, all MVC, because the way it's been built piecemeal over time, ASP.NET as a whole has been very tightly coupled between the application code, our ASP.NET application code, and our server, IIS. Right? It was built, ASP.NET was built historically to run in Windows environments, in IIS environments. That's great, right? But over the last many years, not only in web development, but in development generally, we've come to not really like tightly coupled things, right? We want to sort of break things apart to the extent we can and have, say, our application code, our server, whatever our service is, whatever we need, the dependencies we have that our applications require, we want them to be independent of each other. We don't want to be stuck running our web apps through IIS on a Windows server or whatever, right? With the advent of Azure especially, where we are trying to build web applications that can run on Linux in a Docker container, Kubernetes cluster, whatever, we don't want that tight coupling. Now this started several years ago. Whoever worked with Owen? Has anyone done that? A handful of people? Owen was interesting. Not a lot of people did it. Even though there was a lot of fanfare around it when Owen was released. And Owen was sort of the first efforts in the .NET space to sort of start that decoupling. So instead of using a global ASX, a web config file, we started seeing things where you could take a class, decorate it as your Owen startup class with an attribute, and designate the entry point for your application. So instead of having to worry directly about handling events with application start and application end and request begin and request end, you were able to define a little more clearly how your application ran, and you could self-host it. That was great, but it didn't get a lot of pickup. And so over a period of years, we morphed into ASP.NET Core. And what ASP.NET Core does for us is it takes that and goes a little bit further. Instead of just saying any old class that we decorate, we now have two core important pieces of any ASP.NET Core application, right? We have our program class, and we have, by default, our startup class. And instead of decorating a class with an attribute, we have a startup class that acts as our entry point to walk through configure services, configure our middleware, configure our configuration. And each one of those things is decoupled so we can build it and configure it and compose our applications the way we want. Now, mostly this talk is about dependency injection and the middleware and those pieces. But to talk about that, first, we're talking about the host itself. The host in ASP.NET Core is effectively an object that encapsulates all of the dependent services that we need to run our app. It encapsulates our logging, and it encapsulates our dependency injection, and it encapsulates our hosting and reference out to our server, whatever that server may be, and it wraps it up in one nice little package. And the reason we use it is because instead of having to, because we want a composable application, but we still want it to be easy, having everything wrapped up in one nice little package allows us to start up and shut down our application smoothly, cleanly in one place. It allows us to manage the lifetime of our web application as a whole. I'm going to look a little bit, and the idea mostly for this talk is we're going to talk through sort of what happens in the program class, what happens in the startup class in an ASP.NET Core application, what's going on, and how we can make little tweaks and kind of do things the way we want. So, oh, by the way, who's already using ASP.NET Core 3? Handful of people. Okay. This is mostly going to be like this is ASP.NET Core 2.x. Okay. But because 3 came out and was released in production, what, around like September 21st, 22nd, somewhere around there, right around the time of Takarama, actually. Maybe it was 6 weeks. Yeah. So right around then is when 3.0 was released. Now 3.0 does not have long-term support. 3.1, which is in preview 2, I believe, right now, will have long-term support when it comes out in the very near future. So in a few spots, I will point out things that changed, but the core code samples we're going to use are going to be ASP.NET Core 2.1. Okay? Now, here's the base. Very simple program class. You start a new thing, create a new .NET application, new .NET web application, and you're going to get this. Now, this is the main entry point, right, for our app. Come in a program, and we say we're going to create a web host builder. Now, in earlier versions of ASP.NET Core, even before 2, you created your web host here, and it actually built it and got it all going for you. What was already nice, even in ASP.NET Core 2, is we just create this builder. Right? We're going to create a builder, and the builder is like a factory. Okay, that's going to set up the host for us and allows us to configure the pieces that we want. It does almost everything for us, as we'll see with the default if you want, but you can tweak little things about it. And for whatever reason, even though creating a default builder does a lot for us, it doesn't assign your startup class. So remember I said with Owen, for people who haven't used Owen, you would define a class, you decorate it as your Owen startup, and you'd go from there. Here, this is sort of doing the same thing. You take a class that implements an iStartup interface in the right way, and you can assign it. By default, it's the startup class. Now, I already said this iWebHost builder is a factory. What it does, when we call that guy, is a ton of things under the covers. Because when we create the default builder, we're going in and we're setting up some core-based configuration things. We are setting up Kestrel as our web server. We're enabling IIS integration, which we'll talk about in a minute. We're setting up a logger factory so that your debug output goes to console. All sorts of things get set up automatically with this nice helper function. Remember, ASP.NET Core is open source. So you can go and see this code in GitHub. And it's pretty neat to kind of walk through and see how things are built, how things are set up. But we're talking about a few of the things now. Imagine you didn't want to use the default. You don't have to, right? You can create your own builder. So if we go back and look, so this web host static method that creates a default builder, all it's doing is returning an iWebHost builder, right? Even the useStartup is an extension method on the iWebHost builder. So you can chain these things together. So we're really creating a default builder and already tweaking it a little bit just by setting up what our startup class is. But just as easily, you can make your own. And these are just a handful of the things that happen in the default. We're setting a content route, right? We're setting up Kestrel IIS integration. We're setting an environment. We're going to say, oh, it's development. We can do certain things. But notice Kestrel. Notice IIS integration. So has anyone ever used ASP.NET Core without Kestrel? Nobody. So remember, We're trying to decouple these things, right? By default, we're using Kestrel. Kestrel is a very lightweight server. Kestrel, ASP.NET Core on its own doesn't listen for requests. ASP.NET Core actually doesn't, that's the whole point, right? It does not listen for HTTP requests. So we have to give it a server. By default, we use Kestrel. Kestrel is a very lightweight server that listens for requests, does some things to it, massages that request, creates an HTTP context, and passes that. It surfaces that out to your application. Also, by default, we enable IIS integration because Kestrel is so lightweight that in earlier iterations of it, it had almost no protection against any sort of attack. So there's no limits, really. In earlier versions of Kestrel, there were no limits on concurrent connections. You could easily have a DDoS attack on Kestrel, and so you would have to put some sort of reverse proxy in front of it. By default, we use IIS. You don't have to. First of all, you don't have to do it at all anymore. If you want Kestrel to be your edge server today, you can. I don't know that I necessarily would, but it's safer now than it was, say, a year or 2 years ago. But instead of IIS integration, you can run Nginx. You can run Apache. You can set up something else instead of IIS integration as your edge server before passing things through Kestrel. You don't even have to use Kestrel. Because the point is, ASP.NET Core can be self-hosted. You can use Kestrel. You can use, there's an HTTP sys server, and that's Windows only. It's not a Linux server. But you can use some other server, anything, in fact, that implements the iServer interface that is very similar to what came out of Owen. You can build your own server. You can implement your own server and attach that instead of Kestrel. Now, I said, .NET Core 3 does some interesting things. The web host has kind of died. And instead we replaced it with this generic host. Now, we already did a lot to say we were going to decouple our application code from our server. What Microsoft wanted to do with the generic host is say, what if we don't even want to use HTTP at all? There are cases to use ASP.NET that don't involve actual web HTTP applications. So for example, messaging apps, right? Background tasks, things that are just running. You want to throw something up a container that does not actually listen for HTTP requests from a client. You may have no need for web. And so what the generic host does is it does a lot of the things the web host did, but it strips away all of the HTTP stuff. No Kestrel, no IIS, nothing about HTTP at all. And so instead, if you set up, for those who are already using 3.0, you've seen this. If not, you'll start noticing the slightest little change. Now it's not an iWeb host builder that gets returned from our method. And it's not webhost.createDefaultBuilder, it's just host. This does a lot of the same stuff. It sets up our configuration. And we're going to talk through some of the config and other things in a minute. But it sets up our configuration. And it doesn't set up anything for web. The good news is, at first, when they first announced this, people got a little anxious. I got a little anxious. Because it was the generic host was announced. It's been around. It was available if you're using ASP.NET Core 2. You can. In ASP.NET Core 3, this is the preferred, even for web. And web host has been deprecated. It's not gone, but it's deprecated. So at first, there was no way to get on the web. You had to build all sorts of stuff on your own. If you're using the generic host, just make sure, if you don't use does everyone use the CLI tools? Are people familiar with the CLI tools to create new ASP.NET Core? OK. So if you create a new web application for ASP.NET Core 3 using CLI, this will be done for you. But if you don't, if you're not using a template to get started, make sure if you're using the generic host that you also call configure web host defaults. That will take the pieces that were missing, setting up your startup, setting up your Kestrel and your IIS or whatever else you want to do, and we'll kind of stick it back in there for you. And in just the same way as you could with web host, you can now inside here chain all the same stuff. Not only web host, webbuilder.use startup, but you can modify your configuration. You can use a different server, use different proxy servers, things like that. So you can do the same thing here as you could before, but you need to put it in here inside this little lambda. You can't do it outside through the create default builder. Okay? Now, that's the host. Most of that stuff, and most of the time, you're not going to have to worry about any of that. Okay? So how do we actually configure the app itself? Who loves web config? Really, nobody loves web config. I don't love web config either. So with web config, this was kind of this big place where we could stuff all sorts of things. And there's so much stuff in a typical web config file. But one of the things is we set our app settings, right? We basically create a big dictionary of key value pairs. We set all these things up. And there's a lot of problems here, aside from the tight coupling of web config with ASP.NET and all that. Your web config file is going to be checked into source control. Your web config file, we had to deal with transforms and stuff for different environments, all sorts of things to make our configuration the way we want it. The good news is web config is basically dead. It's not really dead, because IIS uses it for certain things if we're using IIS integration. But for our purposes, building our application, configuring our application code, web config is gone. And it's been replaced with a whole bunch of configuration providers. And there's a ton of them. A ton of them. Not just the ones that we're used to when you set up. Let's talk about those first, though. When we create the default builder, and we just don't add any of our own stuff, we get a set of providers. By default, we're going to get these. Settings files. So if you've seen them, right, your app settings file and an environment-specific app settings file, you're going to get user secrets available by default. You're going to get access to your environment variables and command line parameters. By default, these are available to you when you just create a default web app in ASP.NET Core. I want to talk through how these work, and then look at a couple other things that you can use. So first, app settings. Everyone who's used ASP.NET Core has probably seen the app settings file, is comfortable with it, familiar with it. It's just a JSON file, but not only do you get your app settings JSON, you're also going to get an environment-specific one. So you might have appsettings.json, and you're going to have appsettings.development.json, appsettings.staging, appsettings.production.json. When we set these guys up, an important thing to understand about configuration in ASP.NET Core is it is cumulative. We can stack all these different providers on top of each other, and they all mesh together, as we'll see, in one big configuration for the app. So instead of using just web config and having all our key value pairs, we can set things in multiple files and from other sources, and they'll all be combined together. And last one in wins in the event of name collision. Let's take a very simple app settings file. Now, whoop, click too many times. So if we have a basic file, first off, you can have key value pairs like setting1 and value1, but these things can be nested, right? So I can create a section of my app settings file, refer to my FoodService settings, and inside of that, nest these things. They don't have to be strings, right? So for example, timeout's a numeric type. It's a number. So I can have stacked settings, I can have nested settings, but if I have an app settings JSON file for my development environment, I may have a different URL. And when I have the name collision, because appsettings.development.json comes in last, that URL will override this one. Okay? Moreover, I can add things. So persist, if I had a persist property that comes into my settings and it didn't exist in my main app settings JSON file, but it exists here, it'll just stick them all together. The end result is my configuration will have a FoodService settings section that has the development version of my URL, has the timeout value, and has this persist property when I'm in development. Okay? And what about if I had service settings like credentials? Right? This is one of the challenging things with things like web config and stuff historically. What if I have stuff I just don't want to be visible to anybody? So what we have in ASP.NET Core is user secrets for development in a development environment. So user secrets are kind of a feature of ASP.NET Core that sit outside of your solution, but then get sucked in, and are never really part of your solution files at all. The way we do that is every solution, if you're going to use user secrets, and they are enabled by default. So again, remember, if we use the default web host builder or the default host builder, user secrets are available and enabled to you in development. But in order to do that, your project has to have a user secrets ID. So this goes in the CS project file, right? So we can go in and add a property inside of our CS project file, add a user secrets ID. It does not have to be a GUID. By convention, it's a GUID. It really can be anything you want. Okay? But you put you put your GUID in there. And as soon as you do that, if you can go out and you can manage these, who uses Visual Studio to develop today? Anyone in VS? Almost everybody. I knew VS Code? Okay, some. Right, so in Visual Studio, built in, there are features where you can kind of edit your project's user secrets directly, and it'll open this stuff up. But whether you're in Visual Studio or not, say in VS Code, you can do all these things from the CLI. And you can do it in Windows as well. So built into the .NET CLI, you can call .NET user secrets. And if you say list, as long as you have this guy in your CS proj file, then when you call this from the CLI, it'll say, at first, it'll say, well, you have no secrets. The nice thing is, if you don't have an ID associated with your project, it will tell you. Right, the CLI is smart enough to look and say, you don't have a user secrets ID for this project. We can't even check. So you'll get an error, and you'll know if you've forgotten. Once you have it, if you try to list, it'll say there's nothing, and you can add something. So right from the CLI, say .NET user secrets set. And again, we can nest our properties. FoodService settings, use the colon from the command line to nest an API key. So now, remember, if we're in development, we already had a URL that was our dev URL. We had a timeout of 60 or whatever I said it was. We had that persist property, and now we have an API key. Maybe we have credentials. Who knows what else? And it'll store those on your machine, in your environment. They live in a file called secrets.json. So if you're in Visual Studio, and you've just right-clicked and said, edit my user secrets, what you're really doing is editing this JSON file. And this JSON file, right, it doesn't live in your solution. It doesn't even live in one of the hidden dot folders inside your solution. In a Windows box, it lives in app data or app data roaming. I think it's under app data somewhere, and for you, and then it's buried under there. On a Mac in VS Code like I have, it's in your home directory, /.microsoft/secrets/your GUID, right? And then a secrets JSON file. It is completely outside your solution in a protected area on your machine. The advantage here is that when you kind of do a commit, or you push this code up to GitHub or whoever, your secrets don't go. They're available to you when you build and compile your app, but they don't go into source control. Has anyone ever accidentally pushed credentials or secret info? You don't have to raise your hand and admit it, but no, right? Like but thank you for your honesty. I have, right? It's pretty hard to fix that, right? So you're safe. The downside of secrets is a couple of things. First of all, this is for your development environment. This doesn't work in prod. The other thing is, if I'm working on something, Rulon's working on something, we're all working together on a project, you need to make sure that part of the setup when you bring someone new onto the project is they understand this, right? Because the user secrets, the secrets JSON file lives on your machine, in a location on your machine. It's not committed to source control, so when you bring a new member of the team on, they have to set things up as well. So you got to make sure that's part of the sort of onboarding process of someone who's new to your team, new to your company, new to the project. But like I said, also, it's dev only. So when you get to prod, you need somewhere to go. Now, Azure Key Vault, if you've used it before, awesome. If you haven't, that's OK. That's a whole different, like at least lightning talk. Okay. But whether you use Azure Key Vault or does anyone use, there's secret managers in AWS as well, right? So some sort of production secret manager, you need a place to store those same things, those same variables in prod. And not only do you need to do that, but make sure, seriously, just because you have secrets JSON, don't store your production secrets in your user secrets, right? Like, have different credentials. Because even though you're not pushing it out to GitHub, this is not some super special protected file. Secrets JSON is a text file. It's not encrypted. It's not protected in any way, and if someone wants to go and look through and find it on your machine, or if your machine is compromised, or you just accidentally left it sitting on a table in a cafe and it wasn't locked, the first thing someone can do after they post something stupid on social media and make you look like an idiot, the next thing they're going to do is they can go in and read all those secrets clearly in plain text. So don't put your production secrets in user secrets. But your production secrets have to have somewhere to live because the user secrets will not make it to your staging or your production environment when you deploy. Okay? All right. And lastly, environment. The environment variables. This is really interesting because sometimes I actually forget when I'm using my dev machine that when you include and use environment variables for your configuration in your app, it means all of your environment variables. Everything. thing available that's an environment variable in your dev environment will be included in the configuration for your app. That's probably fine, I guess, on your dev machine, but you know, be aware of what you have on your machine, or be aware of what might be settings or environment variables on your machine, because at compile time or at runtime, it will scrape all of them and put them all in a configuration when you're using environment variables. Specifically, and I only point that out because I think a lot of people think, well, no, it's just like the ASP.NET Core prefixed environment variables. That's not true. So you can prefix, for example, if you have done things with ASP.NET Core already, ASP.NET Core _ environment. Right, it's one of the things that you want to make sure you have set. So that's how you set, say, development or staging or production as your environment for your app. So these prefix variables are read, and they're read in configuring the host. So your host itself, when you create your default builder, these ASP.NET Core prefixed environment variables are scraped and added to configuration for the host process, the web host. Because that way the web host has things like environment and it has its own setup for getting services registered, things like that. Or in .NET Core 3, because of course it has to be different, why wouldn't we want to change it? In .NET Core 3, .NET _. Now, ASP.NET Core, right, those guys will also still be read if you do the thing. Remember with the new generic host, you can also configure web defaults. Right, that's how we get things like all back in there. When we configure our web defaults, these will still get read. But in the event that we're not really running an HTTP process, the generic host will also read these in ASP.NET Core 3 if it's just .NET _, say, environment. But everything else in your environment variables gets read as well. If you're in Visual Studio, you can set your own. Right? There's a launch settings JSON file that lives inside the properties folder inside your solution in a Visual Studio solution. And you can add environment variables that will be pulled into your application, separate from the things that are actually maybe just on your machine or in your environment generally. Or in VS Code, just launch.json, which lives inside the .vs Code folder inside your solution. So you can add your own environment variables right in there, in addition to whatever you might actually have deployed in your environment. And then lastly, one other thing on that point, by the same token of those same files, you can add command line, right? So we can self-host, we can compile and build our web app and run it from the command line and add command line arguments. But in these same places, you can add command line arguments, which, remember, under the default configuration, in addition to our app settings and our user secrets and all this, the command line arguments get added as well. Now, that's the default. So let's take one more second and look at a program, our program.cs. And let's say that we create a new web host builder. You can call configure app configuration, configure app configuration. It's long and right. Or configure host configuration if you only want to add special things for the host process itself. And you can add other providers. So you can add your own JSON files. App settings and appsettings.environment.json, development, whatever, are included by default. But you can have a settings file. You can, with whatever name you want. You can add XML files. You can add any file, like .ini files. That format's available as well, if you use them. Okay? The one I think is really cool, you can add an in-memory collection. It's an interesting use case if you're writing, say, a test project around what you're trying to do. You can construct, in your program class, a dictionary, a string-to-string or a string-to-object dictionary. Fill it with whatever you want. And you can pass that dictionary variable, whatever it is, and you can add an in-memory collection, and it will take those things that you set up right there in, say, your test project, your test startup, and inject those into configuration as well if you want to test various scenarios with things that don't really go into your application in dev or prod. Okay? There's a whole host of these kinds of things where you don't have to just rely on app settings and user secrets. There's all sorts of ways you can add stuff into configuration and tweak it however you want. And note that you don't just have to use a new web host, because the create default builder, this is also true in just the generic host, right? But the default builder is still returning an iWebHost builder, which we can further modify, right? So you can still use the default if you want and then add additional pieces, and it works just fine. And these will come in after the defaults. So when we have, say, our app settings already, if you add additional configuration here, they will just either merge with, or if you have a name collision, override the ones that came before. Questions about any of that? Okay. So once all that gets stuffed in and we have all this stuff into like one place and we've got all our app settings and our user secrets and our in-memory dictionaries and everything else, how do we get all that goodness back out and utilize it? Right, on ASP.NET, we had the configuration manager. Right, we could reach in and do things and pull stuff back out into our app. How do we get that in ASP.NET Core? Well, all of this stuff is slammed together into something that implements iConfiguration. I think the actual concrete implementation at runtime is like a configuration base object. Thank you, configuration root object. And that thing has, in addition to other stuff in it, is really cool when you can inspect it. If you've never done this, stop in the middle of startup somewhere and go and check out configuration and look at it. This is where I realized the first time how much I had in my environment on my machine. Right? There'll be a collection of all the providers, and you can see them listed one after another. You have a settings provider, settings file provider. You have your user secrets provider. You have whatever else. You can look at them, and you'll see them one after another in the order they got loaded, and you can see all those name value pairs. And they're all in one collection, jammed together. And there's a lot of ways that we can get stuff back out. The simplest, although not necessarily the way that you would usually want to use. The simplest is, let's just assume for a moment, and we'll come back to this, just take it on faith for a moment that we have access to iConfiguration in a variable called _config. So if we have that available to us, we can call getValue and type it, right? Because it's a typed call. Get value of a string and go get setting 1. So remember our very first AppSettings JSON file, there was a setting 1 that had value 1 in it. But by the same token, we can use the same nested syntax. So you can say get value of a string and call FoodService settings :API key, and it'll reach in and it'll get that ABCDE string that we set with our user secrets. And you don't have to use get value, and this will be important in a moment when we want to see how we do something a little more interesting than just directly calling the config itself. You can get a whole section back. So we can just get the section of FoodService settings back, and once we have that, you can call get value on that section you retrieve, and you can call get value, get an int, get timeout. Now, that's simple enough, but it's not necessarily the way you want to do things, because we're assuming access to all of the application's configuration. Sometimes we have that. Sometimes we don't. Sometimes we don't want to. So what we're encouraged to do in ASP.NET Core is use the options pattern. And there's a few different ways that you can implement the options pattern in ASP.NET Core. At its core, what that means is we're taking a POCO, a simple class, that represents a chunk of our configuration, and we're instantiating that thing so we can talk to just a simple object and get just the parts of configuration we want and ignore everything else. So take the FoodService settings, which we saw was composed from, the URL came from both app settings files, the main one and the dev one. The API key from user secrets, timeout and persist were from the original settings file and the settings.development.json file. Okay? Let's just create a simple class. There's a few ways we can use it. We're again, for a moment, going to assume we have access to config. You can instantiate an empty version of that class. So I just want a POCO, now I've got an options object. Okay? And then I can go get that section. Not the value, but I'm going to go get the FoodService settings section of my config, which has already been composed. Right? By the time we call this, we've already put together the two app settings files and the user secrets, maybe some environment variables, whatever else we're using. I'm going to go get that completed section out of config, and then on the section itself, call .bind and pass that empty settings object in. And what it will do is it'll parse through everything I have in that config section, attempt to name match it to properties of my object, and if it matches, we'll assign those values. If it's not found, if there's stuff in the section that isn't a property of my settings object, that's fine, it ignores it. If there is a property that's expecting that is missing from my settings section, that's fine. Well, whether it's really ideal or not, I'll say this, it will give you the default value. So if you're expecting, say, timeout, and it was missing from your config, you're going to get 0. But it won't blow up on you. Okay? So you call that, and in the case of the setting and then configuration we have, you would, if you wanted to inspect it, you would basically see, okay, well, we got the API key out of user secrets, we got the other things from our app settings files, great. This is also okay, but still not perfect. And the reason for that is because still we're assuming access to all of configuration. And so if I've got a ton of stuff, not just FoodService settings, but all those environment variables, all the other pieces I might have in my config, and I'm going to inject iConfiguration into some service, into some class, I'm passing all this stuff around. Maybe I don't want that. When we get around it with the options pattern, so that's why we have the iOptions interface. And there's a couple iterations or slight variations of iOptions. The iOptions is a service that we can use to pass around pieces of configuration into various classes without having to pass all of the configuration everywhere that we go. To understand how that works, we'll take a quick step back and talk about services generally. And then we'll come back to iOptions. So let's look at the startup class for a second. The startup class in ASP.NET Core, again, most of you have already seen something like this. If you've used ASP.NET Core, you're familiar. It's going to have two methods in it. The first one's optional. It's actually another thing that's really interesting to look at if you ever want to look at the framework code. It's pretty ingenious the way that reflection is employed, so that if you create a startup class and you ignore configure services altogether, it's fine and the thing doesn't break. Like the way that it actually inspects your class, looks for the named method, makes sure it's there. If it isn't there, injects an appropriate method in that it can run by default. It's pretty cool. But configure services is optional. Configure is not. Configure, we'll come back to in a minute. That's where we set up our middleware and our HTTP pipeline. Configure services is where all our dependency injection happens. So who's used one of these guys? We're like Unity or AutoFac, Structure Map for our dependency injection, IOC containers. Those aren't necessarily dead. Like they're not gone. Some have better support right now for ASP.NET Core than others. But the nice thing with ASP.NET Core is dependency injection is a first-class citizen in ASP.NET Core the way it's never been before, right? And so it's important to not forget about things like AutoFac, because the iService collection and the service provider that comes with ASP.NET Core is very lightweight. So a lot of things that we might be used to from using AutoFac, like assembly scanning and a much wider variety of different sort of lifetime scopes around our registered services, are not available in the iService collection. But for most routine usage, the iService collection is just fine. The iService collection is the means that we use to register various services in the same way that we would with something like AutoFac or Structure Map in our older ASP.NET applications. It's very easy to use. Very easy to use. So first off, remember I said before, let's assume and pretend that configuration is available. So one of the first things I always do, I don't know if I've ever built an ASP.NET Core app that I didn't do this, is I take iConfiguration and I inject that into my startup constructor. So my startup class won't have this by default, right? The default template for startup doesn't do this. But because the default web host, when it is built and run, registers some core hosted services, including iConfiguration. iConfiguration, funny enough, by the time you get into startup, is already available and has already been registered to you. So we can inject that in the constructor before we've ever registered anything else ourselves. So the first thing I do is I inject it so I have access to config. Okay? And then let's look at what happens in configure services. We're going to go back to the iOptions pattern for a moment. There's a few different ways we can do this. So the iService collection, which is what's passed into our configure services method, I can just call .configure, services.configure. And I'm going to configure not a service itself. I'm registering the POCO, right? This was that simple class. This is not a service. There's no methods. That FoodService settings was a simple class that just had the 4 properties in it. And I'm going to configure that POCO. And what I'm going to pass in, I'm saying when you configure it with whatever you find in that FoodService settings section of config. Now I've registered my configuration through the options pattern. When I do that, I'll let you take a picture. There you go. All right, go for it. These slides are also online, so if you want, but I can give you a link afterwards. But by all means, take photos. Once we do that, imagine we build a service. So we've left startup for a second. So now I'm in a new class. I'm going to build a FoodService. I have FoodService settings. Now I'm going to create a FoodService. And that FoodService presumably depends upon the settings I have in my configuration. So what I could have done, because iConfiguration is registered, I could have injected iConfiguration into my service and used iConfiguration.getValue or .getSection and getValue and done that. But instead here, I'm just going to inject the iOptions service that is typed to my FoodService settings. Because I configured it in startup, now I don't pass all of configuration. All I do is pass that chunk in, and settings.value is going to have the instance of the FoodService settings class that has those 4 things, my API key, my persist, my time, all that stuff, without having to pass in anything else from configuration. Okay? Now, there's a couple different ways you can do that. iOptions was the original way. You can still use it. iOptions is a singleton. And iOptions is a singleton that is, if you configure it in startup, it's set at that point in time. So one nice thing about ASP.NET Core, right, is it is possible to register services to register our configuration to reload on change. So we can, without having to pull down and restart up our ASP.NET Core application, we can modify we can modify, say, environment variables in Azure. We can modify what's out there and modify our configuration at runtime while the app is spinning. So the trouble is using iOptions is going to take whatever it was at the time we configured it, and that's what you're going to see. iOptions snapshot is registered not as a singleton, but scoped. Or actually, I think it might be transient. And when iOptions snapshot is pulled, every time you inject that, it's going to be whatever the value is right now. Okay? Alternatively, if you have a long-running service, because this will work fine if you are injecting iOptions snapshot into a class or service that you are also spinning up, say, on every request. Alternatively, what if you need to get something out of your options, and those options themselves are going to be used by some other, say, singleton service? So there's also the iOptions monitor. You can inject the iOptions monitor in the constructor on some service that might be a singleton that will be long-lived for the duration of your app. And maybe that service is going to live for a long time, but it's dependent upon things in configuration that may change over the long haul. So by using iOptions monitor, it actually is managing change, like it's registering changes. So if you inject iOptions monitor into your service, instead of calling .value, call .currentValue, and we'll always be checking it updated as your thing gets updated. So if you're going to have a long-running service that depends on configuration that may change, you want to consider using iOptions monitor. Yep? Good? Okay, what about our own services? What if we want to register our own things? Because it's nice to say, well, we can register settings and configuration, but what if we want to do our own stuff, right? We want to put our own services into our application. So let's look at FoodService again. Say, I know they're the dumbest services that do like basically nothing, but that's fine. So say my FoodService now has 2 methods in it. I have a connect and I have a get foos. But it implements an FoodService interface. This is going to look really familiar if you've used things like AutoVac or StructureMap, okay? If I build a FoodService off an interface, then back in startup, I can simply add it to my container. So I can call services.addScoped, and then I can provide 2 type parameters, the service type itself, the interface, and then the concrete implementation of that service. I can do it a few different ways. I can do this. You can do it this way, which is basically the same thing, but instead of having it be a generic, a typed method call, it's just an add scoped call, and I pass in 2 types. Or I can do it this way. I can say I want to add FoodService. I want to register FoodService with my application, but specifically when I get it, I want this instance of the FoodService. Not just some standard constructed instance of FoodService, but this one. This is valuable if my FoodService depends upon something, if I have to set it up in some way, right? Because I don't just have to create a FoodService. I can pass in my own arguments, my own things to the constructor. So if I need to make sure that FoodService is set up in a very specific way, I can register it this way. Okay? And I said before, like AutoVac has 7 or 9, or I don't know, a lot of different scopes. We have 3 with the lightweight container that comes with ASP.NET Core. We have transient, scoped, singleton. I think they're fairly common terms, but just in case, scoped is kind of the most common, what historically I would have thought of as the default registered service, which is for one request response lifecycle. From the time that I request the thing, the service that gets provided out of the service provider will be constructed, made available to me until the end of that request response cycle, and then it'll be thrown away, and on the next request I'll get a new one. Transient is going to be instantiated every single time I request it, anywhere that it is needed, even if that is more than once within a given request response cycle. And singleton is a singleton, right? You don't need to maybe I'm open to ideas for when you would do this, but don't implement the singleton pattern yourself in ASP.NET Core. You just don't have to. Okay, so you could register a singleton, and it'll just live for the duration of your lifetime of your app. Now, in addition to things like services.addScoped or services.addSingleton, we have extension methods, right? And we've seen a lot of these. So does anyone use Entity Framework in ASP.NET Core? A handful of people. So you may have seen something like this, where off our services collection, we're going to add a DB context, right? And so we're going to add something. And this is notable because it's not only an extension method off the services collection, but notice, I'm not just saying add singleton of a DB context. I am passing something into it. Right? I have to be able to configure my DB context in some way. So this extension method is there to make that easier. Or, as another default example, add MVC. Right? Add MVC exists because it does a ton of stuff. Add MVC is not adding a single service. Add MVC is adding a ton of the different dependent services that we need to run ASP.NET Core MVC apps. And instead of having to add and register all those services one at a time, Add MVC nicely handles all that for us in a single call. Now, one more quick thing with .NET Core 3. Add MVC is still fine. They prefer we not use that anymore. Right? So now instead we flip these things up. So now you can nicely add controllers, add razor pages. You can still add MVC if you want, but if you don't need all those things, you can just add the services you need for the parts of ASP.NET Core MVC that you care about. Add MVC is effectively the equivalent of taking add razor pages and add controllers with views together. Those things combined basically give you add MVC. But you can, and the official line is that we should split them up and just inject the pieces that we want. But all that said, the point of these two things is one of these is an example where we have an extension method off the service collection because we have to add specific arguments when we register a service. Or another one is where we need to do a bunch of things at once and not one service. And what's cool is we can roll our own. Right? We can actually put together our own service extension methods very, very easily. Take a static class like foo extensions. Whatever you want to call it, doesn't really matter. By convention, we call it foo extensions. This foo extensions class is going to have one method in it. It's static. It does a couple of important things. It is an extension method off the iService collection. And by convention, although I guess you don't really have to do it, it is nice to then return the iService collection back. Because really what we want to be able to do is chain these things in our startup class. And by returning the service collection back at the end, we can do that. And inside, I can kind of do whatever I want, but in this example, let's say I need to do a few things in my foo service. Let's imagine, we haven't talked about a factory, but let's say I need a factory that has to do with my foo service. I can add that, and I add it as a singleton. I can also add as a scope service my foo service. And maybe I want to have a special logger for logging foo things that happen, but that logger requires, I'm not just going to add any old foo logger. I want to add a specific one that receives some log path. Optionally, right? So I want to actually configure where I'm going to write this log out to, because say I'm going to write it to a file somewhere, instead of to console or to wherever else. Okay? I can put those three things together, and once I've done that, and back in my startup, I can just call add foo. And so we've encapsulated all that into some other extension method. And so at the end of the day, now what I've done here, just like with add DB context or add MVC or add identity or any of the other built-in available extension methods that we see that come with ASP.NET Core, we built a nice, easy method to consume that can be chained with all the others, that does things, in this case, adds multiple services to my service collection, all in one call, and can be parameterized. So I can pass in an argument like the location of where my log is going to go. Okay? Last thing, this goes, I've got like 10-ish minutes, right? Ish. Okay. Now, you'll just talk faster, it'll be fine. Okay, so the pipeline. The pipeline, this is going to be the other half of the startup class. So looking at configure. So ASP.NET Core gives us the concept of middleware. Middleware, if you've ever looked at the docs for ASP.NET Core, you've seen a diagram that looks vaguely, although not exactly like that. Each piece of middleware, what it is just a class, it's just a component that will sit somewhere along the line between when the server receives the HTTP request and composes an HTTP context and passes it off, and when the application actually does something with it out over here. And in between, that context can get passed from middleware to middleware, and the context can be modified, read, used, whatever, in order. So as we register a pipeline, and I'm going to repeat this a couple times, it happens in order, the order that we add things. So just like when we register configuration, and it matters whether your app settings file goes first or your environment variables go first or whatever else, the order you put your pipeline in is the order it will execute. It'll go one direction into the app, and it'll go back out in reverse order. And each piece of middleware gets to talk to the context both on the way in as a request and on the way out with the response. With the exception that you'll notice in each one of these, we kind of await next. Next is just is a delegate for the next piece of middleware. So in the case of middleware 1, next just really represents the instance of middleware 2, which gets invoked. So when we await next, it's just going to call next invoke of this guy. If for whatever reason we don't do that, so we don't await next on middleware 2, that's OK. There are places where we do that. Even by default in our applications, there are oftentimes where that happens, where next doesn't get awaited. It doesn't get rid of middleware 3 exactly, but what it means is for the request where next is never invoked, this piece just goes away, never gets hit, and we kind of go back out and service the response out to the client. As long as we always await next, we'll get through the whole pipeline and come back through. Now, all this happens to get set up in the other half of our startup class, right? So configure services was the optional method for our service collection, our container, our DI. Configure is for setting up our pipeline. The configure method is going to get at least 2, but can be more. It's at least going to receive the iApplication builder, which is what is used to build and assemble the pipeline for each request response cycle. And it's going to get the hosting environment, because that way we know whether we're in dev or prod or whatever while we build our pipeline out. Optionally, you can add, there's an args parameter, so you can add more stuff after this if there are other things you need to inject that you want to use. So if there are services that you maybe think you need for setting up your pipeline that you registered during configure services, which gets called first, you can add those in here and consume them and use them when you set up the pipeline. Okay? An example of a default version of this method looks something like this. So again, you've probably seen a method a lot like this, or out of the templates. So first off, notice we're gonna check the hosting environment. So, OK, are we in developer mode? If so, use the developer exception page. That's a built-in piece of middleware that just says if there's an exception, don't actually send back a nicely formatted with the error and a stack trace and all those things, because we're in dev. I don't want some obfuscated thing like tell me what went wrong. Give me the exception page so I can see it, and I can debug what went wrong. Notice it's first, because order matters, not only on the way in, but on the way out. So if anything happens after it hits the developer exception page middleware on the way in, at any point in time, we want to make sure it's the very last thing that sees anything on the way out, because otherwise, any exception, wow, oh, I can't wait to walk back to the hotel on that. Sweet. That's great. OK, we'll just wait that out and have some beers afterwards. It'll be fine. So we want to make sure it's first, because then it's also the last thing that gets hit on the way out. Because if anything else came before that, then on the way out, if an exception happens out here, it gets ignored, like it doesn't get, we missed it. So we put the exception handling at the beginning, and therefore the end. If we're not, we want to use strict transport protocol, right? So we'll use HSTS. Then after that, maybe we'll have some HTTPS redirection. And what about use static files? That's important, and its location is important. Use static files is a short circuit piece of middleware. So if the request is for something that is a known static file that isn't, say, an MVC route, we're going to serve that file back and not await next. If you look at what happens inside that useStaticFiles method, that's an example of a time that we just took the rest of it and sort of severed those arrows and moved it out of the way and didn't ever bother with MVC. We didn't look for a route. It's important that this happens here. If we have static files come after we use MVC, then we might try to be retrieving like an image or some other static file, and we're going to try to route that through MVC, and it's not going to work. Okay? So order matters. MVC, I only point this out because I don't have a slide for it, but I will say that, again, with ASP.NET Core 3, use MVC is fine, but there's a new method called use Endpoints So look up use endpoints. Basically what it allows is not only, that way you can call app.useEndpoints, you can put a bunch of different ASP.NET Core things inside of it once. So you can map a default MVC route, but you can also say set up a signal R hub inside this same Lambda here. So you can call app.useEndpoints, set your MVC routes up, set your signal R up, set whatever else you might use inside of there. That's the ASP.NET Core 3-way. Okay, but again, sorry John, I'm going to go like 4 minutes over. Sorry. We can make our own. This is my favorite image of all time because it basically looks like my kids when they come home from school every single day. Really messy and really excited about whatever thing that is they did at school. Okay, so we can roll our own a couple different ways. You can call app.run or app.use. Now, app.run, by convention, is what we use if we're building something that we know is going to be a short-circuit piece of middleware. Right? It doesn't even take the next delegate. It's an asynchronous anonymous method. When I call app.run, it's only going to get the context. So I can do things to the context, like, in the response, write out, I'm done. And that's it. There is no next. There's no await next. So at this point, it's going to start going back out the pipeline and send things back. And among other things, my response will contain the I'm done string. That's with app run. Alternatively, you call app.use. You can do this thing with app.use. You can just ignore next and not do anything with it. So you don't really actually need app.run at all. By convention, that's what you would use if you're building something that you always know will be short-circuited. App.use retrieves not only the context, but also the next delegate for whatever piece of middleware will come after it in the pipeline. So in this case, we could talk, Eric and I talked a bit about like examples of this, but I already knew there was no way that like I'd come close to an hour if I added it. So we can talk about examples of this after John's done over drinks if people want to talk about it. But you can do whatever. Like an example, this might be if you want to do custom. I've done things in production with custom logging. I want to do a special thing that logs the entirety of the request. I want to do specific things, writing out that log to a file, things like that, that don't come with the default iLogger factory. You can configure and set up your logging, get it set up before the request, and then write it out wherever you want to write it at the end. Another good example would be like timing. That was your example, I believe, right? If you want to time how long the request response takes, you can set a timer up, let it do its thing, stop the timer at the end, and record it or add that back to your response when it's done. Okay? So but the point is you do the stuff on the inbound side, then you await next, so that from this piece of middleware it can move to the next one and go down to handle whatever the request is. And at some point on the way back out, it'll pick back up, it'll do whatever is after the await next, and then hand it off to the rest of the pipeline on the way back out. Okay? And you can put that in the middle of your pipeline just like anything else. So this anonymous piece of middleware can be constructed and set to run after our HTTP ESTA redirection and before static files, for example. And it'll just be run in the middle. And lastly, we can create our own extension methods just like the service collection. So if you don't want to do all that stuff, we can create a middleware class. And all that middleware class is going to do is have two requirements in it. First, it is going to have the request delegate. The request delegate is the thing that represents that next piece, which at any point in time is going to be whatever comes after me in the pipeline. So we have to have one of those in the constructor, and then we have to actually define our invoke method, because when we call next, when we await next, what happens is invoke gets called. And that middle stuff is the same logic that we had in our anonymous method. Right? So I had the anonymous app.use. That same logic can be stuck inside of an invoke method in this piece of middleware, in this external class. And now, once I've done that, I can do two things. First, I could just call app.useMiddleware, like this line here, right in startup. But in my opinion, better is we can create another static extension class that takes the iApplication builder, the same thing that the configure method has in startup, and we can call UseMiddleware here. So now, and return it, just like with the service collection stuff. Return it so we can chain them if we want to. Right? If I do that, now we have to do, it's called UseFoo. And UseFoo will go in, it'll look up that extension method, UseFoo will grab the middleware class and do all the things we need to do, and our startup class is nice and clean. We can extract that stuff, make our own libraries, whatever. And lastly, seriously, I was told last time I was here that like pumpkin carving is a thing. We don't do pumpkins here in the Netherlands. I was at a cafe in The Hague this morning, and there were pumpkins on the windowsill. They weren't carved, but like on the windowsill in the cafe. So hopefully this is not a completely lost reference here. But yeah, the order matters because, like I said, exception handling's got to come at the beginning and the end. You've got to have your strict transport protocol before you set up HTTPS redirection, or it does you no good. Right? So think about the order that you do things. So from here, I'm going to pass it off to John. All I'd say is dig deeper into this stuff. Look, it's all open source, right? It's all open source. Microsoft's come a long way in the last several years. So all of these things are available in GitHub repos that you can look at, see how they work, play around, dig in, and see the tools that are available. Because once you understand the tooling that's there, you can leverage them and not just use the templates that come out of the box. You can write your own extension methods. You can write your own middleware. It's really not that hard to do. You can set up your own configuration, use whatever, and it's easy, and you can make your ASP.NET Core app work for you the way you want it to. So keep learning, and let's talk to John. That's me. If you want to reach me, Twitter, email, any way you like. Thanks, guys.